Okay, today we are going to know more on integration of trigonometric functions. Okay, this one we have this. Okay, this one you memorize. And then different integrate cos, you have sine. And then secant square, you have tangent. Cosecant square, you have negative cotangent. So only these four for trigonometric. So this one you memorize. So what happens is, if I want to integrate tangent, let's say I want to integrate this tangent x. Okay, how to integrate tangent? So you see, because tangent is not here, we have sine, cos only, we don't have tangent. So what we do, if you want to integrate tangent you have to use identity. What I mean is, you want to integrate any trigonometric function which is not here, then you use the identity. That means this one can become sine x, then this one is cos x negative 1 dx. Am I right? So now we are going to integrate the negative 1. Integrate the negative 1 will give you the ln, isn't it? This will give you the ln, is it? Then what happened? You want to, what we call, integrate to get negative to get ln, then you have to differentiate this. Differentiate this, is it you get negative? So you add a negative sign, then 1 over negative 1. So the answer is this. So this is the correct answer. Okay. Now next, if I want to integrate tangent square. Okay. Tangent square. So how to integrate tangent square? Again, tangent square is not here. But we have secant square, we have cosecant square. So tangent square, we can use identity, which can be written as what we call, you see, 1 plus tangent square x is equal to secant square x. So tangent square x is secant square x minus 1 dx. That means here, we are going to integrate the secant square. Okay? Integrate this, and then here we integrate the 1. So when I integrate the secant square, what do I get? There is already here. Secant square is tangent. Therefore, you get tangent x, isn't it? But here you have to differentiate the x. Is it you get 1? Then 1 over 1. You don't have to add anything. Then minus integrate this one, you get x then plus c. So this is the answer. Okay, that is how we integrate. So you see, how about, let's say, so you see, when you want to integrate tangent, you use identity, you change to this. You want to integrate tangent square, you change to this. Okay, like here. Okay, I show you here. Okay, then when you want to integrate, let's say I want to integrate now, I want to integrate cos square x. If I want to integrate cos square, I don't have cos square here. I just have cos and sine. So how to integrate this? What we do is, we use this identity. Cos 2x is 2 cos square x minus 1. So cos square x is 1 plus cos 2x over 2. That means when you want to integrate the cos square, it can be written as, okay, 1 plus cos 2x over 2 dx. That means here you integrate the half, and then you integrate half, this is cos 2x dx. Then this cos can be integrated to become sine, is it? That is how you change. So you remember, if you don't have cos square, you don't have sine square, you use this identity. So when you change the cos square, you become cos. Then you can use number 2 to integrate the cos. Then here the sine square also, you can change to cos 2x. Then the cos, the function, the trigonometric function cos, you can use the number 2 to change to sine. I will show you the example now. Okay. Let's say now we have this. This one I showed you before just now. It's more or less the same one. This is more or less the same. Now I want to integrate tangent, but I don't have tangent. I just have sine, cos, secant square and cosecant square. I don't have this. So tangent I change to sine over this. Then it's the same like just now. I want to integrate the what we call negative 1, which will, the negative 1, when I integrate, it will give you ln. And then when I differentiate this, I will get negative 3 sine 3x. So I must have a negative 3 here. I divide by negative 3. That's why this negative 3 negative 1/3 come from here. So integrate the negative 1, you get ln. Okay, so how about if I want to integrate tangent square? Just like what I said just now, we don't have tangent square in the list, but we have secant square. So we use the identity. Okay, so the identity is this one. 1 plus tangent square x is equal to secant square x. So tangent square x is secant square x minus 1. So tangent square of this is secant square of this minus 1. The same angle. Okay, therefore now you see I write it in red color so that I can integrate the secant square to become tangent. Then this one here I integrate to become tangent. So secant square become tangent. But here I must have a half. So 1 over half, which is 2. So these two come from here. Okay, so secant square become tangent. And then integrate, this one is x. Then after that you just substitute 0 pi upon 2. So when you substitute pi upon 2, you get pi upon 4. Then you substitute 0, here you substitute. Then tangent pi upon 4 is tangent 45 degrees is 1, tangent 0 is 0. So this one you get this. Okay, that is how you integrate tangent square. Okay, then after that, let's say you want to integrate sine square, just like what I said just now. Okay, in our list here, we don't have sine square. We have only sine, we have cos, we have secant square and cosecant square. We don't have sine square. So how to integrate? We use identity. So what identity? That's how I show you which identity we use. We use this identity. Cos 2x is 1 minus 2 sine square. So sine square x is 1 minus cos 2x over 2. So I'm going to use. So this x now I change to what? So I change to x over 3. Therefore I get 1 minus cos 2x over 3 over 2, then dx. Then this one is half. And then this one is half cos, this one becomes 2x over 3. So when I want to integrate this, you see, when I want to integrate this, this is x, okay? So when I want to integrate this cos can change to become sine. Cos will become sine, okay? But here I must have 2 over 3. So this is 1 over 2 over 3, which will become 3 upon 4. That's why I get 3 upon 4. So this is the answer. So this is definitely correct. Okay, then if let's say I want to integrate this, again I don't have cos square, but I have cos and sine. So I'm using the identity again. Which identity I'm using? The angle is pi upon 2 minus x. So use again this one. Pi upon 2 minus x, pi upon 2 minus x. So I substitute. So you just refer back to the formula. So this is cos 2 pi upon 2 minus x plus 1 over 2. Okay, 0 to pi upon 4. And then here I separate them. This one, the half taken out, then is cos. That means here I'm going to integrate the cos. And here I'm going to integrate half. So the cos where I'm going to integrate after this cos can be integrated to become sine. This one will give us sine. Cos will give us sine. But here I must have a negative 2, so 1 over negative 2, which will become negative 1 over 4. Okay, then this one is half x, then I get half x, then after that I substitute. Negative 1 over 4 sine, I substitute pi upon 4 here, become pi upon 2. Pi minus pi upon 2 is pi upon 2. Then when I substitute 0, I will get pi. Here I get pi upon 4 minus 0. So after that, sine pi upon 2 is sine 90 degree is 1. Sine 180 is 0. Then this is pi upon 8. Then after that you substitute. Simplify, you get this. Okay? So that is how you do. Okay,